So now, what happens if our circle's not a unit circle, right? We said when we had our unit circle that the x and y coordinates were the cosine and the sine. But if we're looking for the x and y coordinates of a circle with a radius not equal to 1, we actually have to use a slightly different formula. So if I'm on a circle with that doesn't have a radius of 1, the x-coordinate of any point on that circle is actually the radius multiplied by the cosine of the angle. And the y-coordinate is actually the radius multiplied by the sine of the angle. So all that happens when we're on a circle that's not of a radius of 1 is to get the x and the y coordinates, all we have to do is stretch the cosine value or the sine value, or shrink the sine or the cosine value based upon the size of the radius. So for example, if I wanted to find the points on the graph below, I actually have points A, B, and C. So for point A, by the way, notice my radius is always 6. So to get point A, x would be 6 cosine 150. And I actually did this by using my calculator. And so if I did that, I'd end up getting negative about 5.2. And the y value would be r sine theta, so that'd be 6 sine 150. And remember, the sine of a 150 is 1/2, so I end up getting 6 times 1/2, or 3. And I happen to round these to 5 decimal places, so that's why you'll notice some of this. So then I end up getting the full coordinates of the point. Point B is a 195-degree angle, because what I would do is I'd go start at the positive x-axis, and I'm 15 degrees beyond horizontal, so that's 195. And this one, by the way, I can't do in my head. I actually would have to use my calculator. And so to get point B, I'd go 6 cosine 195 and 6 sine 195. And I end up getting about negative 5.8 and negative 1.6. And so again, I can write those as a point on the graph, or a point on the circle. Point C, now I have to be a little careful because I can't see both at the same time. Point C here is 40 degrees beyond the vertical. So let's see, the vertical would be 270, and another 40 would be 310. And so if I do that here, if I go down, I'd be looking to get point C. I'd go 6 cosine 310 and 6 sine 310. And I'd end up getting about 3.9 for the x and negative 4.6 for the y. So there's some questions in the book like this, but it's really actually pretty simple. It's just the new radius times the cosine of the angle, or the new radius times the sine of the angle to get x and y respectively.